Welcome to the video for C1.1.2 where we're going to look at chemical and physical changes. So to start with, I want you to pause the video in a minute and I want you to think about which one of these is a chemical change and which is a physical change. So we've got some chocolate melting and we've got an egg cooking. So write your ideas down, pause the video, write your ideas down, and then wait, and this will be discussed on the next few slides. Okay, so our learning objectives for today are to explain the differences between a chemical and a physical change and be able to list a few examples of each. So keywords first. So the key phrase for today's lesson is chemical reaction. So we've met chemical reactions in year 7 and year 8. You've done plenty. But apart from thinking that it's something exciting that happens in the chemistry class, you might not have thought deeply about what it is. So in a chemical reaction, then the atoms in a chemical or chemicals are rearranging. They're breaking bonds and forming new bonds, and then they're forming a new substance or substances. So we're going to talk about physical changes first. So you need to copy this slide down once it's complete. So physical changes are reversible. And also, no new substances are made. So if you have a physical change, you can easily turn it back into what it was before, normally. And there isn't any new substance. So if we think back to our starter slide where we had the chocolate melting, if I was to unwisely carry a chocolate bar around in my jacket pocket when it was really hot in the summer, then it might melt. And obviously I don't want to eat it while it's melted chocolate. So in order to reverse that physical change of it melting, I could put that chocolate bar in the fridge and it would cool again and it would turn into solid chocolate and then I could eat it. Now, no new substance has been made when that chocolate melted, or indeed when it turned back into a solid. So it's still chocolate, whether it was a solid or whether it was a liquid. It still tastes the same. So it's the same substance. And that's why it's easy to reverse, because it's the same substance. So other examples might be an ice cube melting. So any changes of state or physical change, or things like dissolving. So if I got some salt and dissolved it in water, I would know the salt was there because I could taste the salt water. But if I wanted that salt back, I could evaporate all the water and I could get the salt back. And here's a particle diagram to show what might happen in a chemical change, sorry, in a physical change. So as you can see, the particles are the same on the left and the right. So nothing has changed for those particles. The molecules look exactly the same. So in a chemical reaction, if you look at the particle diagram there, you can see you've got two different substances and they combine to form a third substance. And if you look at how the particles are arranged, they're arranged differently because the atoms are bonded to different atoms in the product. So you've got the light blue circles and the black circles. So in the reactants on the left-hand side of the arrow, the two pale blue atoms are joined together and the two black atoms are joined together. And then in the product, you've got one pale blue and one black atom joined together in a molecule. So chemical reactions are not easily reversed. So there are some that you can change back, but most chemical reactions are difficult to reverse. So it's not easy to get back your reactants if you want to get them back. And one or more new substances are made. So always in a chemical reaction, you are making new substances. So if we think back to our starter slide again, when the egg was cooking, if I've got a raw egg and I fry it, I can't then decide, so that's a chemical change, the proteins have changed structure. So I can't then decide, you know what, I don't really want a fried egg, I'd rather have it scrambled. I can't turn that back into a raw egg and then turn it into a scrambled egg or a poached egg or whatever. So once you've made that fried egg, you can't easily get back the raw egg. In fact, you can't get back the raw egg in that case. So all you need to do now is there are 6 things there. The egg cooking we've just discussed, so that one should be easy. And you just need to say whether it's a physical or chemical change and then say why. So for example, I think an egg cooking is a chemical change because you can't change it back to a raw egg once it's cooked. Okay, so I've done one as an example, so you've just got 5 to do. So write those in your book and then you can email that to me. And if you're feeling fancy, you can do the extension task, which is to write down how would you know if a chemical reaction has happened. And the answer to the extension is on the next slide. So if you're doing that, pause the video now. Okay, so if you haven't still written down the physical or chemical changes, then pause the video because I'm just going to talk you through what the answers were. So the sparkler, if you've got a firework, that's going to be a chemical change because once you've used your firework, you can't get the new firework back. So it can only be used once. You can't reverse it back into a firework that hasn't been used. Okay. If you've got a fizzy tablet that's been dropped in water, so that's if you've got a normal tablet that's dissolving in water, then that would be just dissolving and that would be a physical change. But because you've got the gas being given off, that gas has escaped and you can't get the tablet back. So that would be a chemical change. Sugar dissolving in a cup of tea, so anything that's dissolving is just a physical change. That substance that's dissolved, I could easily get it back by just evaporating the liquid. So if I evaporate the solvent that it's dissolved in, I can get back my solute, which is the solid that's dissolved. So if I have Coke foaming when a Mentos sweet is dropped into it, that's the carbon dioxide that's dissolved in the drink escaping. So that is a physical change because it's just something that's dissolved coming out of it. And then lastly, a match burning. So if I take a match, I can only use a match once. So a match burning is a chemical change because it can't be reversed. I can't get a shiny new match back. I can only use it once. Okay, so this is the last slide that we need to look at. So you need to copy this down into your book. So what might we observe if there's a chemical change? So if you did the extension task on the previous slide, you might have hopefully written a few of these down. So signs that there might have been a chemical change. We might have a smell. So if you can smell something, that might indicate that there's a chemical change. If there's a temperature change, so either the temperature is going up or the temperature's gone down, then that can also indicate a chemical change. If you're generating a gas, so the ones that you typically use at school might be carbon dioxide or hydrogen being given off. If you have a colour change, so a colour change isn't always a chemical change. If you have ever seen sulphur melting, it's a nice yellow powder when it's a solid, and when it melts it turns into a kind of reddy orangey liquid. So that is still a physical change, but most colour changes are down to chemical changes. And then lastly, you might have a precipitate forming. Now, you might not have met this term precipitate before, but a precipitate is a solid that forms when two solutions reacts. So you've probably met precipitate in terms of geography. So you talk about precipitation as being rain, or you can talk about precipitous cliffs in terms of being ones that have got a steep drop. But in chemistry, it means a solid that forms when two solutions react. Okay, thank you for listening. See you next time.